Okay, this is our first example on finding an equivalent capacitor when we have a network of capacitors. So the important thing now is to remember from what you've seen in the theory in your textbook and in the previous videos, is that capacitors in series, okay, are gonna be combined in the same way that we were combining resistors in parallel. And capacitors in parallel are gonna be combined in the way that we were combining resistors in series. So that means we're gonna find first which ones are in parallel. So we see here that this one and this one, they are in series, so that means we can combine them, and the equivalent to two resistors that are in series, two capacitors that are in series is going to be the following. We're going to say 1 over C is going to be 1 over 6 plus 1 over 12. Okay, if we do this math, okay, we are gonna end up with a capacitor that is 4 microfarads. Okay, you can do this math, okay, there in your calculator, and so that means that these two resistors are gone, and now I'm gonna redo the new network. Okay, so the new network is gonna look like this. Okay, it's gonna look like this. And now what we can see is that we have these two are capacitors in parallel. So that means that capacitor in parallel, the equivalent to these two is just adding them. Okay, so we're gonna have 10 microfarads. Okay, microfarads here, because capacitors in parallel, they behave in the way that resistors, or we combine them in the way that resistors were combined when they were in series. So the new network, after we simplify these two, oops, I forgot to wire here. Okay, but so the new network is gonna look something like this. Okay, we're gonna have now 3. We have this other 3. We have here a 10. But now these two, okay, they go here. Okay, they are replaced in these two terminals. Okay, and we have the 10. Now these two, okay, you can see they are in series. So that means that let me do it here in blue. So the capacitor, well, this is a way to do it. Actually, 1 over C is gonna be 1 over 10 plus 1 over 10. Therefore, C, okay, is equal to 5 microfarads. And don't forget, this was a microfarad. Okay, so now the new network, okay, is gonna look like this. Okay, the new network, when we eliminate these two, or when we replace these two capacitors, now it's gonna look like this. Okay, 3 micro, and then these two, they just became, sorry, it's not 10, it's a 5. Okay, here is a 5. Okay, so we have 5. Now, at this point, I want you to see that these two, okay, are in parallel. Therefore, I'm gonna add them. Okay, so it's gonna be 3 micro plus 5 micro. Okay, and that means that now my new network, okay, this is A, this is B, is gonna be something like this. 3 micro, but these two are gone and are replaced by a capacitor of 8 microfarads. And finally, you can see that these two are in series. Therefore, okay, and I'm gonna do this here. Okay, these two are gonna be now replaced by one single capacitor. Okay, and the value of that capacitor is gonna be 1 over C equal 1 over 3 plus 1 over 8. Therefore, this capacitor, if you do this math, you're gonna get 2.18 microfarads. And that's the way that you deal with capacitors that are in series or in parallel.